أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم.
One-way ANOVA comparing three or more group means. Test to compare means one-way ANOVA. The aim of this session is to discuss the testing of differences between mean values on a central variable, that is our dependent variable, that is the variable of interest, between three or more groups. When we examine differences between two groups, we used a form of t-test, that is independent sample t-test. However, when moving to an examination of differences between three or more than three groups, we can extend the same logic of the t-test to a method known as analysis of variance or ANOVA. The main aim of an ANOVA analysis is to evaluate if the means of the samples, that is the groups, are sufficiently different from each other to suggest they are representative of different populations. The main difference between an ANOVA and a t-test is that you can use one-way ANOVA to test if there are differences in more than two groups, whereas t-test is used for two groups. An example would be if you wanted to check to see if there were differences in class attendance rates for first, second, and third year university students in a particular course. So you are assessing the differences in class attendance across the university students who are enrolled in first, second, and third year. Now, what are the different assumptions for one-way ANOVA? The dependent variable, that is the variable of interest, needs to be on a continuous scale, that is, it is measured either on interval or ratio scale. When testing a three or more independent categorical groups, it is best to use one-way ANOVA. Now you should have independence of observations, which means that there is no relationship between the observations in each group or between the groups themselves. For example, there must be different participants in each group, with no participant being in more than one single group, just as we saw in the earlier example, the first year, second year, and third year students. Now, no student can be in 2 years, so there is independence of observations. Now, your dependent variable should be normally or near to normally distributed. What if the dependent variable is not normally distributed? We are going to use bootstrapping, which we are going to do later. There should not be any spurious outliers, not too many outliers or significant outliers. The data must have homogeneity of variance. Now, this assumption can be tested using Levene's test for homogeneity of variance in the statistical package, maybe SPSS or R. Now, if the homogeneity of variance is not satisfied, we are going to use Welch ANOVA, and we are going to use different post hoc tests. Now, what about sample size in one-way ANOVA? A consideration for ANOVA is homogeneity. Homogeneity in this context just means that all the groups' distribution and errors differ in approximately the same way, regardless of the mean of each group. So homogeneity is not about mean comparison, and that is your stage 1 of one-way ANOVA. The first thing is that you look at groups' distribution and errors and whether they differ in approximately the same way. And if that is the case, then we use different kind of post hoc tests. The more incompatible or unequal the group sizes are in simple one-way between subjects ANOVA, that is another name for one-way ANOVA, the more important this assumption is. That is the assumption of homogeneity of variance. Unequal group sizes in factorial design can create ambiguity in the results. A significant result indicates that homogeneity has been violated. Equal cell sizes It is preferable to have similar or same number of observations in each group. This provides a stronger model and tends not to violate the assumptions. Having unequal groups can lead to violations in normality or homogeneity of variance. Now, the ANOVA is a two-stage test. Your stage 1. The first stage is an overall test. This stage tests the overall hypothesis, that is, whether or not there are significant differences for that variable of interest or your central variable across all groups. Not specific comparison between the groups, but overall whether or not there are differences. Now, in this example, you would be looking to test whether attendance rates, that is the earlier example, differ across first, second and third year. I'm not looking at specific differences between first and second year students, first and third year students, second and third year students. So stage 1, just overall differences. Yes, the attendance rates differ across years. For example, that if that is my hypothesis and I want it to be significant as well. Now, if a significant result is found, then only you would go on towards your second stage to check the individual differences between the groups. Stage 2. Now, stage 2 introduces specific procedures for testing group differences. Now, overall, there are differences. Now, what or whether or not there are specific differences between groups or not. Now, this is stage 2. You run post hoc tests that are used when the researcher is expecting to find a difference between the different groups for that particular variable. Now, post hoc tests aim to compare every group, similar to carrying out several t-tests. Now, what is the difference between T's and F's? Now, you will see the T statistics in independent sample t-test and F in ANOVA. So the t-test is an examination of the mean difference and the standard error of the mean difference and only examines the difference between two groups. The F-test examines the variability of the sample means, that is your explained variance. This can tell you if there is a difference between multiple groups, not just two groups, multiple groups. Now, our example in this case, a researcher is investigating bank employees and whether their perception towards the vision at that how a vision is communicated differ between different job levels. So my hypothesis is the perception of communication of vision is the same across all job ranks. That is my null hypothesis. My alternate is there are significant differences in the perception of communication of vision across the job ranks. Now I can have multiple hypotheses whereby I can compare each of the job rank. Now once this hypothesis H1 is substantiated or supported, then only I'm going to look at these other hypotheses, whereby I make individual comparisons. Now here are the books that you can refer to learn more about one-way ANOVA. Now how do you run one-way ANOVA in SPSS based on this particular example? Let us run one-way ANOVA in SPSS. So we go to Analyze, Compare Means, One-Way ANOVA. My dependent variable is vision. How well the vision is communicated and understood. Does this differ between different job levels? So here is my job rank. I want to estimate the effect size. You go to Options. I need homogeneity of variance because the type of post hoc test I want to run will be based on my homogeneity of variance. I need descriptives as well. I'm not going to click Welch for now, but first I'm just going to look at overall differences and press OK. Now you will see multiple tables. The first one is, this is job rank 1, 2, 3. So junior, middle and senior. I've got 90 junior level employees, 206 middle level employees, 44 senior level employees. In the junior level employees, the mean for vision is 4.84. And you see it increases as the job rank increase. It is 5.05 for middle, 5.31 for senior. Overall, the mean is 5.03. This is standard deviation, standard error, lower bound and upper bound confidence interval, the minimum and maximum value for vision in each group. Now the next step after descriptives is test of homogeneity of variance. Now in this case, based on the means, the test of homogeneity of variance is insignificant. This means that your assumption of test of homogeneity of variance is satisfied. So you are going to move to the next step and use this table to assess the main effects. So if you look here between groups, your significance is 0.160. This is greater than 0.05. Now this means that there are no differences in how the vision is understood and communicated across the three job ranks. The three job ranks understand the vision in a similar manner, or the vision is communicated in a similar manner across the three job ranks because the p-value is greater than 0.05. There are no differences in the perception and understanding of vision across the three job ranks. Now, since your main effects are insignificant, we do not need to run post hoc comparisons. But what if this was significant? In that case, we will run post hoc comparisons. So how will we run post hoc comparisons? If your assumption of homogeneity of variance is satisfied, that is, it is insignificant, and let's assume your ANOVA was significant. Let's assume there are significant differences in how well the vision is understood across the three job levels. To do so, what we'll do is, we'll go to Analyze, Compare Means, One-Way ANOVA, go to Post Hoc, Equal Variance Assumed. Why? Because test of homogeneity of variance was insignificant. So let's use Stucky and press Continue and press OK. And you will get a multiple comparisons table like this. Now if you look here, the communication and understanding of vision between junior level and middle level, are there any differences? No. Between junior level and senior level, are there any differences? No. Look at the significance. Look at this lower bound and upper bound. There is a 0 in between all these. Between junior and when you are comparing the junior and middle rank, look at the difference. Look at the lower bound and upper bound. There is a 0 in between. Same for all else. So there is no reason for doing multiple comparisons here in this case because your ANOVA or the main effects were insignificant. But if they would have been significant, this is how you would have compared each group with the other group and looked at the significance, whether or not there are differences. Now, if this would have been significant, we would have said that there is a difference in how well the vision is communicated between junior and middle rank employees. Now, there is another assumption. Let's say this test of homogeneity of variance was significant. Let's assume this is not 0.327 but 0.03. Now, in this case, your assumption for test of homogeneity of variance is violated. So, equal variance cannot be assumed. In this case, we are not going to use ANOVA, but rather what we are going to do is we are going to go back to Analyze, Compare Means, ANOVA, go to Options, Welch test, continue, press OK, and look at this here. Your Welch test is here, and this is insignificant. So this obviously is an alternative to this table here, the ANOVA table. And it is interpreted in the similar manner. And this shows that overall, the communication of vision or the perception towards the communication of vision is the same across the three job ranks. Now, if this would have been significant, we would go for post hoc comparisons. But in this case, since your homogeneity of variance here, since your homogeneity of variance was significant, we were assuming that it was significant. That's the reason we ran Welch test. So if the homogeneity of variance is significant and the Welch test is significant, we are going to go for post hoc comparison. When you go to post hoc, Now we will run equal variance not assumed because your homogeneity of variance was significant. And the reason we are running post hoc comparison is because the Welch test was significant as well. So you can go for Games Howell, let's say, press continue, press OK, and what are your post hoc comparison results, or where are they? Here they are. Again, you can make each comparison between junior and middle, junior and senior. So is the difference significant? No, 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 no. You interpret it the same way we did it earlier when equal variance was assumed and we ran the Tucky test. Now, how do you report these results? Now, in this case, I've got this particular sample here. So you just need to copy the values from your SPSS output. So the hypothesis tests if the perception of communication of vision differs across different management levels. Participants were divided into 3 groups, that is junior, middle and senior. The ANOVA results, so first you are going to report your ANOVA results, suggests that perception of communication of vision scores of the groups differ significantly. Now in this case, our example showed that it did not differ significantly. Differ, okay, did not differ significantly or does not differ significantly. And what is your F statistics? Here is your F statistics. Let's go to ANOVA 1.844, 1.844, and your p-value is 0.161 if I'm not wrong. 0.160. Now, in this case, you do not need to go further and run your multi-group analysis. Now, in this case, since let's assume if you need to run further analysis, that is post hoc analysis, let's try this. Let's try some other variable for this write-up, analyze one-way ANOVA, and let's see if we get significant for any other variable so that we can discuss how to report them. Now for development, this is significant. So let's use development as our example for the write-up. Let's remove this. Let's remove this. For post hoc, I'm not going to use any now. Go to options. Let's do descriptive and all. Press continue, press OK. So homogeneity of variance. Well, your homogeneity of variance is significant. So we cannot use ANOVA. Rather, we will use Welch test. And this is significant. So what we are going to do is, similarly, let's come here. So we are interested in development initiatives, perception of development initiatives. Does it differ between junior, middle and senior level employees? Similarly, you can change here as well, the perception of development initiatives. And similarly, my alternate hypothesis will change. Now, I'm not going to change it right now. These individual ones, you can do it as well if you want. The hypothesis tests if the perception of communication of, or rather if the perception of development initiatives, whether they differ across the different management levels, and these were the levels, the ANOVA results. Now in this case, since the homogeneity of variance assumption was not met, the study utilized Welch test to assess the main effects. The results suggest that the perception of development initiatives differ significantly across the job ranks. So in this case, we do not have F statistics. We just have, what do we have? We have statistic, Welch statistic, and then the significance. So Welch and what is the Welch value? 4.76. Now in this case, your Levene's test of statistic is significant, so the equal variance is not assumed. To check for individual differences between groups, we use post-hoc comparison, we use Dunner-3 or Games-Howell. Now in this case, how do we run it? Just go back here, go to Analyze, One-Way ANOVA, post-hoc, equal variance, not assumed. Let's run Games-Howell, continue, okay. Now here are your results. The multiple comparisons results. You can copy it for, like, this will ease up the write-up process. Now since we found significant differences and we are using Games-Howell, just mention the test. Now the test indicated that the mean score for junior level employees was significantly different from senior level employees. Now first what I'm going to do is I'm just going to paste in that table so that I can easily compare the results out of it. Window, let's reduce the size a bit. So junior and middle. Junior level employees, you write in the mean and standard deviation. Where do you get the mean and standard deviation? Simply come here and look at this here. The descriptives. So the mean value for junior, the mean value for middle, and their standard deviation. You simply have to copy them and paste them here. Was significantly different from senior level employees. Was this the case? Yes, this is the case. You do not need to report every single comparison. Just report the significant comparisons and mention the rest of them are insignificant. You compare the middle level employees to senior level employees, and again the mean values shall be reported for senior level employees. Now the mean differences were significant at 0.05. However, no significant differences were detected between junior and middle level employees. Now table 1 summarizes the results. You do not need to mention all the details. What you can do is you can have this format here. So your age groups, their mean values, their standard deviation, Levene statistics, significance, F, and significance. Now, in this case, you are going to use Welch rather than the ANOVA results because the homogeneity of variance test was insignificant. So you can mention the statistic here and then the significance. And similarly, you can do group differences from this table. So this is how you can create the table for group differences and overall results. I hope this session would have been helpful in performing one-way ANOVA results. Thank you very much.